textbook, this is lesson 9-2, so we're on your notes. Page 5 as you are looking. It says I can sketch a quadratic. We've been doing that using the points. X-intercepts, we're going to be talking about that a little more. We did the Y-intercepts. We're going to still keep talking maximum and minimum. And now we can explain where those maximum and minimums are because of our vertex. As we look at this new one, it says in the previous lessons we worked with quadratic functions that had no middle term. Today we're going to look at quadratics that have a B term. So our bx as we are looking at that, okay? So all of ours are going to have a middle term. So this is our standard form of polynomials, highest degree squared. Then we go to x to the first. This is going to move our parabola. So as you are taking a look, our essential understanding, as you take a look at this, says in the quadratic function ax squared plus bx plus c, the b affects the position of the axis of symmetry. So that b affects the axis of symmetry, which means it affects the x-coordinate. When we think of our axis of symmetry, right? Remember we said the axis of symmetry is always going to be x equals, and it's going to give us this equation. So that b is always going to affect it. And here's what happens. When you have y equals 2x squared plus 2x, it moves the vertex over here to x equals negative 1/2. Okay? So if I'm looking at x equals negative 1/2, and I look at my b term was 2, and my lead coefficient a was also 2. In the next equation, I take a look, and I have y equals 2x squared plus 4x. This time, x equals negative 1. 2x squared plus 6x, my axis of symmetry is at negative 3.5. That's also the x-coordinate of my vertex, right? So it says, notice that the axis of symmetry changes with each b value. The equation of the axis of symmetry is related to the ratio b divided by a. So in our equations, if we are looking at b divided by a, we are going to take in this first one, our b divided by a, 2 divided by 2 gives us 1. Our axis of symmetry was negative 1/2. Here we had 2 and 4 for our a and b. b divided by a is 2. Our axis of symmetry was negative 1. Negative 2 divided by 2 is what we were looking at. It's divided by 2, which gives us 3, and they said the axis of symmetry is negative 3/2. So the question is, how do we find that equation for our axis of symmetry? Do we see a pattern as we are looking at this? And this is what I need for you to write down. The axis of symmetry is always going to be this equation. Negative 1/2 times b over a. Or, a lot of times, we will write it as just negative b divided by 2a. This is going to be part of later in this unit when I start to sing our quadratic equation song. You will also. But this is going to lead us to that. That's part of why we are going to be using it. So when we are looking at that negative b over 2a, this is going to be key that we have to write down in all of ours today. So this will be our vertex. So we need practice with this. So we are going to be asked to graph. And as you do your homework tonight, you notice on the board that I put, for each equation that you're doing, you're only doing the 9 questions. You have to show finding the x and y coordinate of the vertex. You're going to do a table with the vertex in the middle, and then you're going to graph it, and sometimes you might have to look at the scale. So, if we are looking at this, this is exactly what you'll be writing down for each homework question. You'll put the equation. Next thing we might want to do is identify what is our a, b, and c. So if we are looking at this equation, my a happens to be what? Negative 1, which means my parabola is going to go up or down? My parabola is going down, right? I already know that because a was negative 1. My b value, 4, positive 4, and c happens to be negative 2. We don't really need the c in this part. We will when we get into our quadratic equations. So on your paper, you'll write this equation, then you'll put this equation down next. You'll put x equals negative b over 2a, which in our case, negative b, which is 4, divided by 2 times negative 1. So we're going to end up with negative 4 divided by negative 2, which is 2. Positive 2. So at this point, what we just found was that our equation for the axis of symmetry is x equals 2. That's kind of nice when I think about my graph, right? Because I already know now that this is my axis of symmetry. So please put that. Axis of symmetry, right? Our parabola has to be symmetric on both sides of that. So now it says, let's find the coordinates for the vertex. Well, remember, the vertex is an x, y coordinate. You just found the x is 2. How do we find the y? You go back to your original equation. In that original equation, you are going to replace every place where there is an x here with 2. So we're going to have negative. It is 2 squared. And my recommendation is put it in parentheses because if that ever comes out negative, some of you will forget and when you square a negative, it is positive. So we just need to be careful for that. So you can put negative 2 squared. Then we have plus 4 times 2 minus 2. And if you like, you can have your calculator out, and I have more calculators up in front if you need one. So if you're putting that in, this is 4, right? So that's going to be negative 4 plus 8 minus 2. So my y coordinate should be what value? Should be 2. If you got something other than 2, remember, negative 4 plus 8 is 4. 4 minus 2 gives us 2. So y was equal to 2. Yes?
But isn't the c value
The c doesn't, no, the c is not part of this. This is where we're starting. So make sure you have this. So our coordinates is 2, 2, which is nice. We can now place that on our graph, right? 2, 2. It says now pick 2 or 3 points that will be on the graph. Use your line of symmetry to your advantage when picking points. So we do not always want to pick 2 positive and 2 negatives like you did last night, right? When we did lesson, the first lesson in this one, we always started and we said, oh, when you pick your x and y values, pick 2 negatives, pick 2 positives. You don't want to do that anymore. My note on the board says, once you find the coordinates of your vertex, we are still going to pick 5 points, but we are going to put right in the middle our vertex. Because on both sides of the vertex, since it's going down, it has to be symmetric. So if I know like that one of the points is here, I know the other one has to be over here. It has to be symmetric, right? We don't know where that's at yet. So we're going to put 2, 2. We already solved for the y coordinate in our vertex, right? So we have 2, 2 right in the middle. So now we want to pick points that are close to 2, 2. So I'm going to go with 1 and 0. Oh, that's nice, 1 and 0. 0 is going to be super nice when I plug it in, right? And then on this side, I'm going to go with 3 and 4. Because I know that 3 is the same distance that 2 is away, or that 1 is away from this point 2, which is my axis of symmetry. So I am now going to go to my equation up at the top. And in that equation, you were asked to write y equals, it is going to be negative 0 squared plus 4 times 0 minus 2. Well, that's really nice, right? Because 0 squared plus that, it's just going to leave us with 0, negative 2. Okay, question?
So in the homework, do we have to write out the equation with each coordinate?
You don't. You can actually show this work, but I'm going to write it down because some people are like, how'd you get that value for y? So, and the other thing is if you make mistakes, and I don't see your work and it's on a quiz, I'm probably going to mark it wrong because I have no idea what you did putting those numbers in your calculator. Okay, so Gavin, you writing this down? We're going to put negative, then we're going to have in this case, what are we substituting in? 1 squared plus 4 times 1 minus 2. This will give us negative 1 plus 4. Subtracting 2, we should get positive 1. When you plug in 3, what do you think should happen? So if we are graphing at 1, it was here. 1, 1. At 0, it was down at negative 2. What do you think, if this is my parabola and axis of symmetry, what do we think we should get for when we plug in 3? We think we should get 1. And you might want to always kind of do the check because sometimes you're off on your axis of symmetry. We're taking -3 and you're squaring. That doesn't mean you're squaring -3, right? It's going to be 9 and then it becomes negative. But then you have +4 times 3 minus 2. So this is a -9 plus 12 minus 2. Does it give us 1? And so now that I have that one, what do you think is going to happen at 4? What value should I get if it is symmetric? It should come out -2. And again, like Kylie said, you can plug in 4 in your calculator and just do that work. And you should get -2. So what's really nice about parabolas is if you put this vertex right in the middle, it will be symmetric. These two should be the same. Once you plug in your x, your y coordinates for those should be the same. So you really are not having to solve for 5 points, right? You really need to solve for, once you find the vertex, you find 2 other ones, okay? So again, plotting that last one. And then in your homework, usually I'm going to be asking you to show your line of symmetry. So axis of symmetry, right by this, we would put x equals 2. So in your homework, when you look at this, I will look for your axis of symmetry, giving me the equation. So not just putting the AOS, putting x equals 2 with that, which we found right away, and then graphing your parabola. So we want to look at a story situation with this also. So let's take a look at this next one. So it says, in lesson 9.1, we used h squared. H is equal to -16t squared plus c, where h was the height from the ground of an object. Its initial height, c, is where it started off at. And an object is projected into the air given the initial upward velocity of v. It continues with no additional force acting on it, so like the wind isn't blowing, right, or anything. This is the formula that we are going to use to approximate its height from the ground. So if you're throwing a football, you're throwing a baseball, right? They're shooting t-shirts into the air at a game. Okay, they all have the same thing. So it says we're going to spend the entire lesson later on really working on these pretty heavy, where we have that velocity. So it says during a halftime basketball game, slingshot launcher launches t-shirts to the crowd. The t-shirt is launched with an initial upward velocity of 72 feet per second. T-shirt is caught 35 feet above the court. How long did it take the t-shirt to reach its maximum height? What is the maximum height? So these are going to be the questions. How long did it take? How long would be what? Time, right? So it's going to be time in seconds. What is the maximum height? In this case, it's going to be in feet. And then it says, well, what is the range of the function, right? So that's kind of like our domain and range. What are the possible numbers that we could have for our function that as we are looking at that? So that next page is where we're actually going to start doing the problem. So here is our equation. The function is -16t squared plus 72 plus 5. So 72, right, from that last problem when we were looking at that. That was our, when they told us in the problem, that was our velocity, 72 feet per second, right? So that one times the t. This is how high they were shooting it. So the first question, how long will it take it to reach its maximum height? How long is time? Now, when we look at this equation, we are looking at it in terms of time, comma, height, right? So time is like our x coordinate, height is like our y coordinate. So how long will it take to reach that maximum height? What we really need to find is our axis of symmetry. So first step, we are going to put t equals, the equation is -b divided by 2a. In our equation, a happened to be -16. Again, if you don't have a calculator, you might want it for this one. The numbers get a little unclear. B is 72. And we really don't need the c value, but c is 5. Okay? So we are going to plug in 72 over 2 times 16. And you can, negative 16. And you can leave your answer as a decimal. What'd you get, Mary? 2.25. Came out positive, right? Which it has to come out positive, right? If you're sending it with time, it doesn't make sense. So really watch those negatives and substituting that in as a negative 16. So this comes out to be 2.25. So can we answer the question, how long does it take to reach its maximum height? Right now we can answer that question. It is 2, what were we talking about? Our time was in what variable? Seconds. So we're going to say 2.25 seconds, right? If we're looking at that. The next question says, well, what was that maximum height? That's the y point of our vertex, right? So our second thing that we have to do now is we need to find the y point of our vertex. We're going to use that equation. So our second thing is we're trying to find h. H was equal to, if we look at our initial equation, negative 16. You're going to plug in 2.25. This is why you want your calculator squared. You should be able to put this whole equation in your calculator. Plus 72 times 2.25 plus 5. Check with your shoulder partner and see if you get the same number when you please put that in. Maximum height, our maximum height is 86 feet, right? If you've ever been to the force game, you know, where they're shooting them out of that huge t-shirt shooter and they shoot them out, that's looking at those. And it says, well, what is the range of our function? Okay? So the range of our function, if we are looking at it, if this is our maximum height, right, of 86. So you're picturing, right, it started at 5 feet, right? So the person was standing here, they're shooting it into the air. This is our maximum height at 2.25 seconds and 86 feet, right? That's our maximum, that's our vertex. And now it starts coming down, right? So if we are looking at that, and the question says, what is our range of our function? Our range, if we're looking here, and it says, where does it say the person caught it at?
35.
At 35 feet. So they're over here someplace, right? They caught it and it's at 35. Above the 5 feet, right? Obviously not drawn to scale, right? Not a good scale drawing on my part. So the question number 3, what is our range? Our range is going to be, if we look at that, when we look at that, the lowest that our height was what? 5. So we're going to say h is going to be greater or equal to 5 feet. And the maximum height was 86 feet, right? Because 35 is someplace in between there. So if we are looking at it, you could write it this way. You could write it in words that the range is going to be between 5 to 86 feet inclusive. Okay. So I would take it any way like that. Okay. So next one down in your notes before we get you started. So it says, from a height of 5 feet, the sling latches a t-shirt to a crowd at a basketball game. It launches the t-shirt at an upward velocity. So this is really our C value, right? That's where we're starting at 5 feet. This is our B value at my velocity in feet per second. And the person caught it at 35 feet. So again, they're up 35 feet. How long does it take the t-shirt to reach the maximum height? So the first thing we are trying to find is our time, right? How many seconds? That's the first question they're asking you. How long? So when you see that word how long, that is time. How far above? So the second thing we're looking for is the height. How high up did it go? And again, both of these two things are from our vertex. This is the time, this is the height. And then it says, well, what is the range of it? So the third thing is, we know already the bottom, right? 5 feet for our height. And now we just got to find the top one. And the top should be the same as our height here, okay? So these two are going to be the same. So again, you have to start off with that equation. So to find the x point of our vertex, I need everyone to say this. We're going to say it a couple of times. I'm going to put x here, but it is also like the t, right? So you could use x or t. So t is equal to, I need everyone, negative b divided by 2a. Okay, so for the x coordinate of our vertex, okay? Everyone ready? X coordinate of our vertex is equal to negative b divided by 2a. The x coordinate of our vertex is negative b divided by 2a. So, in our problem, what was, if we look at that equation, the equation for height is going to be, it's always negative 16t squared. We just found the 64. That was our velocity, 64t plus 5. So if I'm filling this in my equation, I'm going to have negative 64 divided by 2 times negative 16. Please put that in your calculator so we get our time. Comes out to equal, kind of nice, 2. So what time will it reach the maximum height? 2 seconds. We now have just found our time. We need to find the h. So now you're just going to go to your equation, h equals negative 16, again, 2 squared, plus 64 times 2 on your calculator. You should be able to put that whole string of numbers in your calculator. And when you do that, our height comes out to be, it is up at 69. So again, we have from 5. Even though they're catching it at 35 feet, that kind of doesn't matter if we were just going to look at that. Question. So when you look at your homework, we're only doing questions 20 through 29. I'm going to hand out this graph paper, and I will strongly suggest that symmetry, negative 2 squared plus 4 times negative 2 minus 5. This is a positive 4, right? Plus negative 8 minus 5. What's nice at this point is you pretty much have where your vertex is located. What do we get for a value? So our vertex is at negative 2 and how much? Negative 9. So we had negative 4 minus 5 gives us negative 9. So on my graph paper right now, right, I know that this is a parabola that goes up. And I'm going to go to the point negative 2, negative 9. I'm going to make like a 10 by 10 grid, right, as I'm doing this, okay? The next thing you have to do, my directions next say, make a table and put the vertex in the middle. I do not care if your table, your XY table goes this way, and you put the vertex in the middle of negative 2, negative 9, or if you like an XY table this way, and you put negative 2, negative 9, right? But the vertex is always going to be right in the middle when I look at yours. So I know that if I'm looking at this, that this is my vertex, and this is my vertex. And then when I put my other 2 points, I want to pick points that are like 1 unit away. Now sometimes that vertex comes out to be a fraction or a decimal. What do? If you get like a half, you might want to pick, if you get that the vertex is at 1/2, You might go 0 and 1, they're both 1 away, and then you might go 1.5 away. So just keep picking them symmetric away from that vertex point. So if we were picking points, someone want to tell me a couple numbers that we probably want to pick here?
0,
-1 and 0, those are going to be the same distance. And over here I'd want to go with negative.
-3 and -4.
So that when I draw that graph, I should see it being symmetric. So I do know that this takes a lot longer. I'm not collecting it tomorrow. There's only 9 questions. And I do think I have up